In this video, we're going to do some exponential regression and function composition practice. So we have the points 1, 4, and 3, 8 that lie on the graphs of the two functions. F of x is equal to mx plus c, and g of x is equal to a times b to the power of x, where m, c, a, and b are constants. Determine the sum of m plus b to the nearest hundredth. So first, we can take m as our slope, and we're going to take 8 minus 4 and 3 minus 1 is equal to 2. Essentially, we're just finding the slope, which is change in y over change in x, which is y2 minus y1 over x2 minus x1. So this was going to give us 2. So a times b is equal to 4. So we know that a times b to the power of 3 is equal to 8. So if you have a times b to the power of 3 over a times b, that's going to be 8 over 4. Now, b squared is equal to 2. So that means that if you take the root of both sides, we have that b is equal to just 2. So square root of 2. So that is approximately 1.41. So if we take m plus b, that is equal to 2 plus 1.41. That is equal to 3.41. So our answer is going to be 3.41. Now let's continue to our next problem. We have the population of a small town is growing at an exponential rate. The table below shows the population of the town over several decades. Use a calculator regression to find the model p of x for the population of this town, where the input value x is the number of years since 1980, and identify the population predicted by the population for 2025. So what we need is to enter this data into list into our calculator with 0 representing 1890. So we're going to use an exponential regression to determine the model and store it directly into a y variable for accuracy. Then we're going to use the prediction for 2025 using the table at x is equal to 2025 minus 1980, which is equal to 45. So your calculator should look like this. You should have two lists, list 1 with the x values and then list 2 with these y values. You can set up your exponential regression like this. You're going to store your equation y1, and then you're going to calculate. Your exponential regression should look like this, and you should get this value for a and this value for b. So then this should be what your graphed exponential equation should look like. Now your answer should be, for the population number in 2025, that should be 10,201 right here, which corresponds to the year of 45, which is going to be 45 years beyond 1980, using that as our base value. Now, let's continue to our next problem. Let's say we have the concentration of a medication in a patient's bloodstream decays exponentially. The samples are taken in hourly intervals, and the concentration of the medication is measured and recorded in the table below. Use an exponential regression to determine the model of C of x for the concentration of the medication at hour x. Compare the predicted values with the actual values for each hour. If E is the error in the model, then what is the largest value of the absolute value of E? So at hour 0, we have in concentration in milligrams per milliliters 2.0, and that continues. So what we should do is we need to store this data into our calculator. Then we're going to use an exponential regression to determine the model and then store it directly into a y variable for accuracy. So if we plot the original data along the graph of a model, we're going to see that the largest error is going to occur at x is equal to 0 and also x is equal to 2. So this is what we're going to have. For exponential regression, we have L1 and L2, and we are going to store our equation in the variable y1. So when we have our exponential regression, this is how your graph should look like, and your A should be 2.15 approximately, and B should be 0.56 approximately. So here we have our lists again, and we can see that using our tables values that are generated in the model, we can find these errors at x is equal to 0 and x is equal to 2. So let's calculate those errors at x is equal to 0 and 2. So we're going to have E of 0 is absolute value. We have 2.1513 minus 2, and that's equal to the absolute value of 0.1513, aka just 0.1513. So then you have E2, and you get the absolute value of 0.6875 minus 0.8 absolute value. That's going to equal to the absolute value of negative 0.1125, and that's equal to 0.1125. So our largest error is going to occur when we are between 0.15 is less than E is less than 0.16. So we can see that our answer is going to be option C. Now for our next question, we have given f of x is equal to x minus 3 divided by 2x plus 4, and g of x is equal to 4 minus x squared. We want to evaluate the function of f composition with g, 5 over 2 as the input. So what this means is we can rewrite this as f with the input of g with the input of 5 over 2, and we're going to evaluate this one at a time. So for this part, we have g 5 over 2 is equal to 4 minus 5 over 2 squared. This is the same thing as 16 over 4, and this is 25 over 4. So we get negative 9 over 4, and this is equal to negative 2.25. Now, if we take this and substitute that back into function f, we're going to have function f composed with negative 2.25. So we're just going to value it here. We have negative 2.25 minus 3 divided by 2 times negative 2.25, all plus 4. So you get negative 5.25 divided by negative 0.5, and that's 10.5. So that matches with our option D right here.